I landed under a mountain of steel just as the cavern light snapped from white to emergency red. The CMS detector towered above me like a mechanical city turned on its side, and all around it, magnets throbbed, coolant hissed, and alarms began striking the air in sharp, panicked bursts. A wrench lifted from a workbench without anyone touching it. Dust curled upward. A hanging cable bent toward empty space as if gravity itself had forgotten the rules. I hit the railing, steadied myself, and shouted the only honest conclusion I had. Something down here was pulling on the world. I ran with the CERN scientists across the platform while sensor towers flashed impossible values. Nobody was speaking in theories now. They were speaking in load limits, tunnel stress, magnetic stability, and evacuation thresholds. One team member pointed at a readout and shook a hand that would not stay still. The fluctuation was local, not global. That made it worse. If the whole machine failed, they could shut it down. If one pocket of space near CMS was warping on its own, then something far stranger was taking hold. By the time I reached the control room, the place looked like the inside of an emergency beacon. Crimson monitor light washed over exhausted faces, and every screen showed graphs punching above expected collision ranges. These were not the beautiful, messy traces of ordinary high-energy physics. These were spikes with edges too sharp, timing too neat, behavior too disciplined. I have seen accidents across centuries. This did not feel like one. The CMS control room team tried a containment sequence, then a beam adjustment, then a partial shutdown. The numbers dipped for half a breath and surged back harder. Not across the collider, but through one narrow band. One invisible throat cut through their maps as if something were drinking from the machine in measured sips. That was the moment my stomach turned. We were not looking at a detector failure. We were watching an extraction. To understand why that terrified me, you need to know where I had landed. This was CERN in 2012, one of the great cathedrals of modern science, built not for worship, but for questions. Beneath the border of Switzerland and France, the Large Hadron Collider hurled particles around a vast underground ring at astonishing energies, then smashed them together so humanity could study what spilled out. We were not breaking matter out of recklessness. We were probing it because the universe does not explain itself for free. And at the center of the excitement was the Higgs Boson, the famous particle tied to the Higgs Field. Popular culture called it the God particle, which I have always thought sounds more mystical than helpful. The real wonder is better than the nickname. The Higgs Field helps explain why fundamental particles have mass at all. Confirming the Higgs boson meant confirming that this field was not just elegant mathematics, but part of the actual machinery of reality. CMS and its companion experiment, ATLAS, were built to catch the faint aftermath of these collisions. They were monumental instruments designed to notice fleeting clues hidden in sprays of debris. Years of engineering, calibration, argument, patience, and hope were compressed into moments like this. If the evidence held, this would be one of the most important scientific confirmations of the century. If the evidence was corrupted, then history itself could be bent before the world even understood what it had seen. I looked around that red-lit room and saw not abstractions, but people carrying years of work in tired eyes and coffee-stained notes. Some had probably slept in shifts for weeks. Some were watching numbers they had chased for half their careers. And hanging over all of it was a pattern I recognized from my earlier encounters with the hidden hand. First they tampered with surveillance, then they slipped into digital control. Now, standing beneath the Earth at CERN, I understood they had graduated from manipulating information to manipulating physical law.